Assalamu alaikum students. Today we are discussing the topic MCQs paper 1 for IGCSE or 5070 chemistry. Energy from chemicals means exothermic, endothermic. How does energy produced by the chemical chain, or how does chemical change occur in presence of energy? These types of reactions are generally known as thermochemical reaction. So question number 1, which change is endothermic? How can we say that which reaction is exothermic or endothermic? It is very simple to answer. If you remember, methane is the fossil fuel burning with during the burning of the fossil fuels, gas, petroleum, diesel, similarly candle, even carbon or wood, they must emit heat energy. The A should be the exothermic. Similarly, hydrogen gas, chlorine gas, when they combine together, they produce an HCl. This is called addition reaction, and all addition reactions are exothermic reaction. Water from gas to gas is split. Decomposition is endothermic reaction. Gas splitting, solid splitting. So option number C is the correct answer for the question number 1. While option D, remember, water molecules change into solid. This is release of energy is exo. A, B, and D are exothermic. Only option C is endothermic. The correct answer is C. This is the correct answer of this question. Now we have to proceed our question number 2. The combustion of methane is an exothermic reaction. The equation is given below. What can be deduced from the fact that the reaction is exothermic? Option B is correct for this question. Reason behind it, all exothermic reactions, energy absorbed for bond breaking is endothermic. Energy absorbed for bond breaking is endothermic, while energy released for bond making is exothermic. So we can say that this is H2 or this is H1. If bond making energies Bm is less than bond forming, so reaction is exothermic, and bond making energies are greater than bond forming. So bond making, bond breaking. Bond breaking energies are less than bond forming, so it is exothermic, and bond breaking energies are greater than bond forming, so this must be the endothermic. This is the logic behind it for the exothermic, endothermic. Now we have to consider our question number 2. What can you deduce from the fact that the reaction is exothermic? Less energy is involved, bond breaking, then is involved in making bond. So beta, if bond breaking energies are less than the bond forming energies, the reaction should be exothermic. Now we have to proceed our question number 3. This equation for the burning of hydrogen in oxygen is shown. What does this equation indicates? Burning. Hydrogen gas burn and oxygen gas is supporter of combustion. So this is also the reaction. What does this equation indicates? Two hydrogen moles reacts with 1 mole of oxygen, produce 2 mole of steam. So option D is correct for this question. 2 moles of steam can be obtained from 1 mole of oxygen. Option A, B, C are incorrect. The reason is 2 atoms of hydrogen combined with 2 atoms of oxygen. Half statement is correct. 2 atoms of oxygen is there, but beta 4 atoms of hydrogen towards your reactant side. So option A is incorrect. 2 gram hydrogen, it is wrong. 2 plus 2, 4. So 4 gram hydrogen combines with 1 gram of oxygen. It is also wrong. 4 gram of hydrogen reacts with 32 gram of oxygen. Then 36 gram of steam is formed. So beta option C is also incorrect. 2 moles of steam, okay, 2 moles of steam can be obtained from 0.5 mole. Even we have 1 mole of oxygen here, 1 mole of oxygen. So option D is correct for question number 3. Now we have to proceed our question number 4. The diagram shows the step by step which carbon dioxide can be converted into organic compound, organic product, and finally return to the atmosphere. Carbon dioxide in reaction A change into C6H12O6. This is glucose. Carbon dioxide convert into C6H12O6. This is photosynthesis reaction. So option A is correct for this reaction. Why does option B and C and D are incorrect? In the organic chemistry, we have to learn glucose change into ethanol by using absorbing oxygen and evolving carbon dioxide. This is called fermentation. Fermentation is the process of exothermic. B is exothermic. C2H5OH ethyl alcohol reacts with ethanoic acid, change into ester, or alcohol by absorbing oxygen, change into ethanoic acid, CH3COOH. This reaction is also exothermic, while organic compound when burned in presence of air, they produce carbon dioxide. So option B, option C, and option D are exothermic, but carbon dioxide produce glucose through the photosynthesis. This step is called endothermic reaction. Was question 4, option A is correct. Now this is called energy profile diagram. We have learned in the previous section in the lecture of energy from chemicals, okay, what is the energy profile diagram. Now we have to see it again. Now you can see that the left hand side diagram is called endothermic reaction. Reactants are below side and the product are upper side. The graph should be maintained by using the dotted line or continuous line from downward to upward. This is the original energy of reactants, H1 till H2. So the reaction proceeds by absorbing the heat. That is why more energy can be absorbed. But this is the difference here, product are formed. So reactant convert into product. So more energy is needed. This extra amount of energy which is absorbed by the reaction, this amount of energy is called activation energy. So this diagram is called energy profile diagram for endothermic reaction, and this is called energy profile diagram for exothermic reaction. The graph shown from upward to downward, so the energy is decreased. This red sign shows the energy is releasing, while reactants just release energy, matter convert into matter as term of product, but little amount of energy should be release. That is why sign of delta H is negative for exothermic and sign of delta H is positive for endothermic reaction. Now we have to discuss the question back again. How does we draw the energy profile diagram in the questions given? The reaction pathway is given here. The energy profile diagram for the reaction between hydrogen and chlorine is shown. One thing should be learned by our heart or must be kept in our mind. This type of reaction, when the reactant are above side and product are below side, this must be the exothermic reaction. Exothermic reaction. So question number 5, some informations are given here. A, B, C, and D. Types of reaction, it is exothermic. So option C and D both contain exothermic. The sign of delta H should be negative for exothermic and delta H sign of delta H should be positive for endothermic reaction. So question number 5, option D is correct. D. This is the correct answer of the question number 5, option D. For the question number 5, option D is correct because this reaction pathway is the exothermic reaction. Now, question number 6. The diagram shows the energy profile of a chemical reaction. Two energy changes are labeled X and Y. X and Y. Reactant are upper side and products are below side. Definitely, it must be the pathway of the exothermic reaction. What is X? Which statement about the reaction is correct? With a Y, this is the extra amount of energy which is released, delta H, while X is the activation energy, if you remember. X is the activation energy. This is the extra amount of energy which is needed to convert the reactant into product. That is why when heat is absorbed, so it is called endothermic. But this amount of reactant just convert into product by releasing extra amount. Initially, some amount of energy is absorbed and then amount of energy is released. So energy changes profile diagram is for exothermic reaction. Which statement about the reaction is correct. Activation energy of the reaction is X plus Y, wrong. The enthalpy change of the reaction is X, no, enthalpy change is Y. X is the X activation energy. The enthalpy change of the reaction is X plus Y, it is wrong. X is the different thing, Y is the different thing. Both are different. We can say that X is the activation energy only. It can be denoted by EA. While Y is the delta H, change in enthalpy, change in the state of reaction. This type of sign is called delta H. Y is the delta H, X is the activation energy. So the sign of delta H is just negative because amount of energy arrow of downward side. So downward side means release. This arrow is upward sided. It should be the absorb means positive. So option D is correct for the question number 6. Now we have to proceed our next question, which is question number 7. This is calculation based numerical. The enthalpy changes from methane, butane, and octane are burned completely in oxygen are shown below. Methane formula CH4 and the amount of energy which is released, it is given 890 kilojoule. Butane is the another organic compound formed as C4H10 2877. Octane C8H18 look like petroleum minus 5512. But all the values contain negative sign. It must be shown as they are exothermic reaction, which are the enthalpy changes delta H when propane and pentane are burned completely in oxygen. Keep this thing in your mind. Formula of propane is C3H8. It is between ethane or butane. But a three carbon atom, so enthalpy change should be less than 2877, while another name of the compound is pentane. We have 5 carbon atom along with a 12 hydrogen atom. So the value of C5H12 must be the greater than butane, and the propane C3H8, this is called propane, and the C5H12 is called pentane. Pent means 5, prop means 3, meth means 1, eth means 2, prop 3, but 4, 5 means pent, 6 means hex, 7 means heft, and 8 means oct. So propane value kilojoules per mole, so pentane value kilojoules per mole. Keep this in your mind. Beta, pentane value should be less than 5512 but greater than 2877, because after butane we have pentane, or before butane we have propane. Option A is correct for this question. Option A is correct. Reason is butane values minus 2877, while propane has less carbon, to 2220 assumed. So minus 2220, it can be mingled, can be fixed between methane and butane because propane has less value than butane. Why? Another thing, minus 1560. So beta, it is must be very short. It cannot be considered as C minus 1560. It is little bit less than the butane. Now propane, 5512. So beta, it is 4210. So question number 7. It is the beta just question related to the IQ level. Just consider the value minus 8902877. How much difference between them? The two members are here. After methane, we have ethane, then propane. So values between the two members is 2222. Question number 8. This is another energy profile diagram. The diagram shows an energy profile diagram for a chemical reaction both with and without a catalyst. With a catalyst, basically, a substance can decrease the activation energy or speed up the chemical reaction. So which energy change is the activation energy for the catalyst reaction? Listen, this way A is without catalyst, long path, while the B is the short path, conversion of reactant into product directly. So which is the shortest path, A or B? B is the short path against the A. So option B is correct. Option B is correct. This is presence of catalyst B. This is absence of catalyst A. So A is the activation energy. You can mark it in this way. This is A. More than. More activation, less speed of reaction. Less activation energy, more speed of reaction, because activation energy is inversely proportional to the catalyst. Activation energy EA, rate of reaction is inversely proportional to the activation energy. So 1 upon EA. If EA is less, rate is high. If EA is more, rate is low. So option A is correct for question number 8. Now we have to proceed our question number 9. This is the calculation technique. It's very simple. How we can calculate the question number 9 answer. Nitrogen and oxygen react according to the equation. Equation is given. Nitrogen is 1 mole. It is given 1 and 2, and oxygen has 2 O2. Ratio is 1 is to 2. They produce 2 NO2. Overall change is plus 66 kilojoules. Okay. The enthalpy change for the above reaction is 66 kilojoules. If 2 moles of nitrogen and 2 moles of oxygen are used, what will be the enthalpy change? How can we answer this question? Is it 66 kilojoule or 132 kilojoules? How can we calculate? The upper relation is given. 1 nitrogen is needed, plus 2 moles of oxygen is needed. So ratio is 1 is to 2. But the second part of the question, you have given 2 moles of nitrogen, but oxygen moles are only 2. We needed 4. We needed 4. But given is only 2. 2 moles are given. So beta, if 1 mole of nitrogen combined with 2 moles of oxygen, 66 kilojoule per mole energy is needed, but we just increase the moles of nitrogen, but oxygen numbers cannot be increased. So out of 2 moles of nitrogen, only 1 mole of nitrogen combined with 2 moles of oxygen. That is why option C is correct. Because there is no change in the value. If nitrogen ratio is 1 is to 2 with the oxygen, if nitrogen are 2, so oxygen should be 4. Then the value multiply by 2, multiply by 66, then is equal to 132. But the ratio is given. If you think 1 mole multiply by 66 remains 66. But in the second part of the question, if 2 moles of nitrogen and 2 moles of oxygen are used, so beta we needed 2 moles of nitrogen, so beta 2 more mole of oxygen, so means 4 moles of oxygen are needed, then option D is correct. If I change the question in this way, if enthalpy change if 2 moles of nitrogen and 4 moles of oxygen in the reaction part. So what will be the enthalpy change? Then correct answer should be D. How? To multiply by 66, then it became 132. Consider the question again, please. Equation has given an hint. 1 mole of nitrogen 1 mole of nitrogen combined with 2 moles of oxygen, then 2 moles of NO2 are formed. During this reaction, 66 kilojoule energy is absorbed. Yeah, in this way, 66. If you are given only 2 moles, oxygen are 2 moles and nitrogen are also 2 moles. One thing is greater, look like a limiting reactant. One nitrogen combined with two oxygen, so 2 moles of nitrogen combined with 4 moles of oxygen. But the question is given 2 moles of nitrogen, 2 moles of oxygen. There is no change in answer. But if 2 moles of nitrogen combined with 4 moles of oxygen, then we can say that 132 kilojoule energy should be given. Should be given. Now we have to proceed our question number 10. Which pair of statement about the combustion, burning of a carbohydrate and its formation by photosynthesis is not correct? Keep this thing in your mind. Combustion means burning, photosynthesis is endothermic reaction, or combustion is exothermic reaction. Combustion, chemical energy converted to heat energy. What is in combustion? Suppose carbon look like glucose C6, H12, O6. This is called glucose plus oxygen change into carbon dioxide plus water vapors and heat is released. This is called combustion. This is called combustion. While photosynthesis is a revert process, just like that. What happened in the photosynthesis? Very simple. Carbon dioxide molecules combined with water vapors, then they produce C6, H12, O6 by absorbing heat energy. So this is photosynthesis. So photosynthesis means endothermic. The upper reaction is exothermic. Okay. अब जरा समझिए. Glucose is the matter chemical change into heat, while the photosynthesis chemical energy converted into light energy. Photosynthesis. So question number 10, option A is correct. How? Chemical energy converted to heat energy, that is why heat is released, and into photosynthesis chemical energy converted to light energy. One thing. Question number 10, option D. Combustion is exothermic or photosynthesis endothermic? No. Correct answer is D, not A. Not A. D is the correct answer. Because chemical energy converted to heat energy, this statement is correct about combustion, but about the photosynthesis is not correct. Light energy convert into chemical energy, but the written statement is reverted. Chemical energy converted to light energy, this is wrong. Question 10, option D is correct. Option D is correct. Now we have to proceed our question number 11. Question number 11, energy profile diagram for a reaction is shown. Because this energy profile diagram, reactants are below side, products are upper side. So you can say that amount of energy absorbed, one thing, while this is activation energy. Both the arrows are upper side. So red arrow means absorbing heat. This is endothermic reaction. Which statement is correct? Which statement is correct about this reaction? Activation energy of the reaction is H3 minus H1. H3 minus H1. Activation energy of reaction is H3 minus H2. Now we have to draw our arrows again. This is EA and this is absorbed heat. So which statement is correct? Delta H बराबर है H1 minus H2, H1 minus H2. Delta H is H1 minus H3. This is wrong. Higher to lower. Option B is correct. Boy, the activation energy of the reaction is H3 minus H2. This segment can be used to calculate. So option B is correct. Boy. This is the question number 11 answer. Now we have to proceed. Question number 12. An endothermic reaction initial enthalpy is more than the final enthalpy. Initial enthalpy is more than the final enthalpy. The initial enthalpy is less than the final enthalpy. If the water is heating over the stove, initially its H1 is less than the hot water. This is H2. So question number 12, option B is correct. Boy. Initial enthalpy is less than the final enthalpy. An endothermic reaction, both the question are same, an endothermic reaction, but options are different. Bond breaking energies are more than the bond forming energies. Listen it again. Listen it again. The reason is if bond breaking energies are greater than bond forming energies, absorbed heat is more, absorbed heat is more, then reaction is endo. But bond breaking energies are less than the bond forming energies, reaction is exo. In other words, you can say that the bond breaking energies are endothermic are more than the bond forming energies. So beta, you can write the correct option as A. Bond breaking energies are more than the bond forming energies. Bond breaking energies greater than are bond forming energies. Reaction is endo. Bond breaking energies less than bond forming energies. This is called exothermic. Question number 14. Which of the following is an endothermic reaction? Combustion means exo. Combustion means exo. Formation of carbohydrate and oxygen from carbon dioxide and water. This is photosynthesis. Oxidation of carbon to carbon dioxide. This is combustion. Carbon burned in presence of air to produce carbon dioxide. Reaction between hydrogen and oxygen means formation of water. You can see that this reaction is exo. A, C, and D are exothermic, but only the option B is photosynthesis endothermic reaction. Formation of carbon dioxide and oxygen from carbon dioxide and water. This absorb energy, carbohydrate, and oxygen from carbon dioxide and water. This is endothermic reaction. Question number 15. It is the same question as question number 1. Endothermic reaction. Number A, combustion. Hydrogen plus chlorine, HCl gas is formed. So gas. This is addition reaction, exothermic. AB, exothermic. Water, decomposition reaction. Solid change into gas, no problem. Gas change into gas, no problem. Gas into liquid, liquid into gas, no problem. All of them are endothermic. This reaction is called, this reaction C is called decomposition reaction, and decomposition reaction are the example of endothermic reaction. While liquid to solid, while liquid to solid, so liquid change into solid by evolving heat energy, so which change is endothermic. So liquid to solid, also the example, releasing energy, release means exo. So question number 15, option C is correct. Last question, the diagram shows the pathway of a given chemical reaction. Reactants are above, then the products. So this should be the exothermic reaction. Exothermic reaction. G. Which information correctly describe the effect of catalyst on the activation energy and the enthalpy change for the reaction? Listen, guys, there is no change of enthalpy change. Either catalyst is used or catalyst is not used. Presence of catalyst or absence of catalyst, there is no change of enthalpy change. Which information correctly describe the effect of the catalyst on the activation energy, with the activation energy decreasing, activation energy decreasing, or delta H no change. So question 16, option D is correct. When we add catalyst in the reaction, activation energy should be decreased. So question number 16, option D is correct. No change in the enthalpy reaction, delta H cannot be changed. Cannot be changed. How? For example, here is a equation. Like 2H2O, this is hydrogen peroxide. When it decomposes, it produces oxygen gas and water. During the reaction, delta H value is 76 kilojoules per mole. This is absence of catalyst. But presence of catalyst, same equation can be written with a little change here. Presence of catalyst. If the first reaction is taking place, suppose within 15 minutes without catalyst, but second reaction is performed only 4 minutes to completion, 4 to 5 minutes to completion with catalyst. But there is no change. Its delta H remains same, 76 kilojoule per mole. That is why question number 16, option D is correct, decrease and no change. Now this is the part 2 paper, a structured question related to energy from chemicals. Hydrogen react with halogen to form hydrogen halide. To form hydrogen halide. Predict which halogen react most violently with hydrogen. Keep this thing in your mind. We have specific halogens, fluorine, chlorine, bromine, iodine in the group number 7 elements, and the reactivity decreasing up to down because they are non-metals, and reactivity is increasing in the metallic group from down the group. To predict which halogen react most violently with hydrogen, answer should be fluorine. Fluorine. Halogen to form hydrogen halide. So beta most reactive halogen is fluorine, then chlorine, then bromine, and then iodine. Question number 2, A1 part B. The reaction between hydrogen and chlorine is exothermic reaction. Exothermic reaction. Delta H sign is negative, which show that reaction is exothermic. Now explain in terms of bond breaking and bond forming why this reaction is exothermic. So you have to write these words for the answer of this question, because this reaction is exothermic. The bond breaking energies are less than the bond forming energies. That's it. Or the initial enthalpy. Energy is more than enthalpy H2. So the example is burning candle. Before burning the candle, the height of the candle is more than the after passage of some time where the candle is lit. So burning candle gradually decreases its size. So initially its energy is more than the final enthalpy or energy H2. So both the wording can be used to show your answer here. The bond breaking energies are less than the bond forming energies. So beta breaking means endothermic, forming means exothermic. So bond forming energies can release more energy than absorb. So this is called exothermic. And all the languages should be returned or reverted. If the reaction is exothermic, the word just change less to more than, and more here change into less than. If the question contains the word endothermic, the languages just change by changing the single word. The bond breaking energies are more than the bond forming energies. It should be endothermic, or the initial enthalpy H1 is more than, the more can be replaced by less. Example is here for endothermic reaction. The temperature is less for the cooking material when it's placed on the cooker. All material in the cooker, and cooker is placed over the stove, burning stove. Initial temperature is less, and after passage of some time, more temperature because lot of amount of energy has been absorbed by the cooking material in the cooker. So these wording can be changed by only changing two different words. Just less can be changed into more, and more can be changed into less. The overall language just change into endothermic reaction. Endothermic reaction. Now the next part, 1 mole of chlorine molecule reacts 185 kilojoule of energy is released. Calculate the amount of energy released when 1065 of chlorine molecule react. Now 106 should be changed into first into change into number of moles by using this formula. N is equal to mass over mr. Now 106.5 is the given amount of chlorine. 106.5 divided by 71, because chlorine means 35.5 plus 35.5 becomes 71. So now when you use the calculator, 106 6.5 then divided by 71, answer is 1.5 mole. Now relation is given here. 1 mole of chlorine gives 1 mole chlorine gives 185 kilojoule energy. So 1.5 moles gives how much energy? So with a cross, make a cross multiply. 1.5 multiply by 185. 1.5 multiply by 185. Answer is 277.5. Answer is 277.5. So this is the answer of the part of this question. 277.5. This is our answer. So you just calculate the answer by using the relation, but keep this thing in your mind, please. All the students, keep this thing in your mind. They are the 7 or 8 elements. They exist diatomic molecular form. So mass of hydrogen is 1 given in the periodic table, but 1 multiplied by 2. So its molar mass should be 2. Similarly, nitrogen is N2. Its molar mass, its relative atomic mass is 14. Multiply by 2. So it becomes 28. So 28 must be used. 28 must be used. Similarly, oxygen O2. Similarly, fluorine F2, Cl2, Br2, iodine 2, I2, and astatine, the last member of group 7 element, At2. These 8 elements, their molar masses must be the double, must be the twice. That is why we just use the relation for chlorine 35.5 multiply by 2 becomes 71. So this 71 number just used for the calculation of MR as MR for chlorine. Now we have to proceed in the next part of the question. Photosynthesis is an endothermic reaction. Now, how can you write the answer in terms of bond breaking and bond forming energies. I told little bit earlier how does bond breaking and bond making energies can be used for define the exothermic or endothermic reaction. The bond breaking energies are more than the bond forming energies. That is why reaction is endothermic, or the initial enthalpy reactant is less than the final enthalpy. Enthalpy means energy of products. That is why this reaction is endothermic reaction considered. Complete the energy profile diagram. Complete the energy profile diagram for this photosynthesis reaction. You have to label. Photosynthesis is endothermic reaction. How can you draw the energy profile diagram? This is endothermic reaction. So beta, this type of diagram should be for here. We have to write products, while some other labels are required. Just like that. This is additional amount of energy which is required. This is activation energy. So enthalpy change for the reaction delta H. How? This is the products. Similarly, activation energy delta H. Where is the delta H? Delta H is there. This is activation energy, while this is delta H. So this is only the products you are just labeled, because endothermic reaction product are upper sided than the reactant side. Now we have to check our diagram again. We have to compare. This is left hand side is the endothermic reaction profile. Reacted to product, this is activation energy from product side, not the from the below to upward, from this side. This is energy profile diagram. Endothermic reaction. Products are labeled here, reactant upward here. This is H1, this is H2, and this is H3. Now, we have to mark one more thing again. Now, we have to move our next question, which is question A3, topic energy from chemicals. Ethanoic acid is manufactured by the reaction between methanol and carbon monoxide. Reaction is given. This is exothermic reaction minus 137. The upper diagram was for endothermic reaction, and this is for exothermic reaction. Now we have to draw it again. This is energy profile diagram for exothermic reaction. We have to write here products, draw a line in the dotted form. From here, this is delta H, while this is activation energy. This is EA, activation energy, and this is delta H. So when the reactant are upper side and the product are the below side, we know that this is the activity related to the exothermic reaction. To label the diagram in this way. One more thing for your consideration again. This type of graph also given in the paper one as MCQs. This is the room temperature RT, and the line is given in this way. So this type of reaction also known as exothermic reaction. Keep this thing in your mind. Don't be confused at all. Temperature is increasing, and afterward temperature is decreasing up to the room temperature. The another graph just like that. This line is the room temperature. For example, 25 degrees C, 20 degrees C. But the reaction curve start from below and then touch it again. What do you think? Temperature is decreasing first and then heat is absorbing. So kindly note these two different diagrams. This diagram for endothermic. First heat is released and afterward heat is absorbed. So the below the line room temperature is down and then absorb energy until room temperature is reached. While this diagram is this graph is exothermic reaction. In this manner, temperature is increasing by evolving the heat, and afterward, when the providing the heat is dumped, then the value of temperature decreasing till room temperature. This is called exo. The heated pot can be removed from the stove and can be placed over a table. So the hot vessel, container, and pot, decreasing the heat, evolving the heat. So it became exothermic now. So hot body just evolve its temperature or heat till room temperature is being availed. Now this is the part for question A3. Now we have to move our next question. Now this is the another part for our consideration, activation energy for endothermic reaction or exothermic reaction. The left hand side material is the exothermic reaction. Reactant are upper side and product are below side. So with the delta H sign is negative. So this is exothermic reaction. We have two different energy levels. So the same diagram should be drawn for the all exothermic reaction. And this type of diagram should be drawn for the all type of endothermic reaction. This is the simple aspect for draw the diagram. H1, H2, H1, H2. Here you can see the change here. H1 is upper and H2 is lower. So initially exothermic reaction, H1 is more than H2. H1 is more than H2. So the formula should be H2 minus H1. So in the reactant side, for endothermic reaction, delta H sign is positive. The reason is when the heat is absorbed, the total amount of energy is increased. But this is the part of the activation. So all endothermic reaction, more activation is needed. And for exothermic reaction, we have little, we have little or less amount of activation energy. This is the reason behind it for all type of exothermic and endothermic reactions. So this is the part of the energy from chemicals. How can we identify exothermic, endothermic reaction? So how does we produce or draw the energy profile diagram for the exothermic or endothermic reaction? Now this is the finished level of the topic here. Allah Hafiz. Inshallah, we will see you again in the next lecture. Kindly, Allah Hafiz. To Sir Ahmed Shah ko Allah Hafiz. Goodbye. Allah Hafiz.